Good evening, everybody. Welcome back to the atomic structure quantum numbers. We'll see once again. Should have seen actually the why Bohr model has failed because he has not considered the Heisenberg uncertainty principle and de Broglie's wave nature for electron application. So then Schrodinger has proposed the along with the Heisenberg, he proposed the quantum numbers and all. We will see. N is a principal quantum number. N starts from integer 1, 2, 3 and it will give the size from the nucleus how far it is there. First is 1 and second is the second KLM shells and all. Then next these are the quantum numbers arrived on solving the Schrodinger equation, which is a very complicated equation. Psi square is the more appropriate this thing, and then azimuthal quantum number, this will give the orbital angular momentum and this one. So L starts with 0 and n minus 1. The next quantum number is M, that is magnetic quantum number. Magnetic quantum number starts from minus L to L. We have seen. Now slightly we will go for the applications and why these are all important. Why actually these quantum numbers are required and psi or psi square Schrodinger equation is required. Say how to fill up the electrons in an atom. That is one question. Second, if at all question, how many in each orbit? Orbital has gone, orbit is gone, of course. Now orbitals have come, Bohr model orbitals and all. So these are the fundamentals which are involving in the chemical reactions and hereafter and all these things. So this is the basic requirement. How to fill up, where to fill up, how much is the radius, how much is the energy level, all these things, which electron will participate, all these things. For those things, these are the fundamentals. Now, small examples and we'll see. If n is equal to 1, that means in the first principal quantum number 1, that means it is only one first orbital. This will be in as 1s, because we have seen KLM and all, and the sublevels are the S, P, D, F is this thing. Now n is equal to 2, you take n is equal to 2, there are two cases. Case A is n is equal to, in the case A, n is equal L equal to 0, this is case A. Case B, L equal to 1, because you see L equal to 0 and n minus 1. 0 is 0 and n minus 1 equal to 1. This 2. That means L equal to 0 and n is equal to 2. This is 2s. Whereas n is equal to L is equal to 1, it is 2p. Right. Now take n is equal to 3. In this, there are three cases. A, n is equal to 3, L equal to 0. Here, in this case also, you can see n equal to 1 and 1s, L equal to 0 and m equal to 0. Here, L equal to 0, m equal to 0. Here, L equal to 1, we have already seen. M equal to G, here, what is this? Minus L to plus L. That means minus 1, 0, 1. This is m values. Okay, that means in the subshell, yes, there is no further shells. In the P, there are 3 subshells. Remember, see, minus 1, 0, 1. So this is the subshells. This is subshells of the S in the neo subshell, 2s. In 2P, there are 3. L equal to 0 is one case. That means this is 3s. In this case, L equal to 0 means m equal to 0. The second case, L equal to n minus 1, that means 2. L equal to 1 and L equal to 2. There are the 3 cases. L equal to 1 is 3p. The 3p we have already seen, minus 1, 0, 1. L equal to 2, it is called 3D. That means how many? M minus 2, minus 1, 0, 1, 2. This is the minus L2 plus L, we have to write M. And L equal to 0, N minus 1. So N minus 1, so 3. There are how many subcells? 1, 2, 3, 4, 5. In the P there are 3, in D it is 5. These are they like this. Okay, now that means if you see, though it is not correct, I am writing though probability theory as per theory and all, but I am writing a very near this thing. This is the K. In this K, only one S will be there. The next orbit is KL. In this 2S and 2P. In the 2P, again there are 3. Okay, third level if you take, there are 3S, 3P, 3D. In 3P there are 3. In 3D there are 5. 1, 2, 3, 4, 5. These are subsets. Yes, it is only one. Like this will go on, then F also will come. For N is equal to 4, F will come. So, F only we are maximum we have and all these things. Those these are the cells and subsets values. Spin quantum number always you know then. Then what is the Aufbau principle? Aufbau principle is for how to place the electrons in the subshells. Electron will go to first the lowest energy level. Who will say how to say the who is the lowest energy level? Then he himself has given this thing. N plus L value, if it is least, that should be the first to be filled. Our principle is how to fill up this thing. N plus value should be the least minimum value. Now we will see one example. So take N equal to 1K, N is equal to 1 case or to whatever is the case. In the first case, one is N is L equal to 0, N equal to 1, N equal to 1 case, only 1, that is 1s. This is the least or first or whatever it is, so there is no ambiguity in this. In the case of N is equal to 2, there are, we already seen, there are two cases. One is L is equal to 0 and another is L is 1. In this case also 2s. That means after 1s, the next lowest level is 2s. Why not 2p? Now the question is, why not 2p? Why is only the 2s after 1s? So here N plus L value is, N value is 2, L value equal to 0. In this case, it is only 2 plus 0, N plus L value. In the case of 2p, this is 2 plus 1, that is 3. So, 2s is the lowest, then 2p. So, it will go to 2p, electron will go to next to 2p. 1s, 2s, 2p. Then, okay. In the case of N equal to 3, we have seen what is 1s, 2s, 2p. Oh, yeah. Then 3s or 3p, which one? Again, same rule. 3s will come first. Why? Because N equal to 3, L equal to 0. So, it is 3 plus 0 is equal to 3. Now, you may have one more confusion. This is also 3, this is also 3. So, which one is, whether 2p is lower or 3s is lower? The next rule is, first one is N plus L is least. If N plus L is same, like this, whichever is N is lowest, that will be the first. So, here 2 is low, 3 is higher. So, 2p is the lowest value, then 3s value. Okay, understood I think. N plus L is first to be considered. If N plus L is same, then whichever is the N is lower, that is to be considered. So, okay. If this, again 3p is coming. 3p value is 3 plus 1, 4. Then comes to 3d. 3d value is 3 plus 2 equal to 5. So, but this will be coinciding with the next N equal to 4 value also. Whether 3p will come or 4s will come and all. So, the rule is same. So, it is to be applied like this. So, Aufbau is told like this. Then next comes to the theory of the what you call the no two electrons will have all the 4 quantum numbers. That is the another theory by the Pauli's exclusion principle. That also we'll see. Before that, shapes of the orbitals also is considered. Very simple this thing, 1s or 2s or 3s, it is always in the shape of a spherical or circle. normally it will be called circle. But don't forget that 1s also spherical, 2s also spherical, 3s, 4s, whatever it is spherical. But all sphericals are not same. There are the what you call the probability densities will be different. Those things will be different, but the prima facie it will be a spherical these things. We'll see the other shapes of the orbitals and then Pauli exclusion principle, then filling up of this one, then how to, which one is stable, more stable, and all these things also we'll consider as per the energy levels and all. Thank you very much.